Hello, can you hear me? Can one of you confirm? Okay. Can you confirm that you can see the screen? Yeah, fine. Thank you. Shall we start the class? It's 6 minutes already. We are waiting for others. Hello. Yeah, so I'll be starting now. Can you see the question now? Yeah, so I'll be starting right now. So here we are discussing the question number 17 from GATE 2022 paper, which is of set 1 civil engineering. So first we'll read the question. For different soils, thing is, whenever you can't see the slide, whenever you can't see the question or whatever, immediately you respond and you let me know. Okay, I'm assuming that you are able to listen, also you are able to see with the slide and all. Okay, so this is what I am assuming, and you let me know if anything is going wrong. So coming to the question, 4 different soils are classified as CH, ML, SP and SW as per the unified soil classification system. Okay, which one of the following options correctly represents their arrangement in the decreasing order of the hydraulic conductivity? Okay, here hydraulic conductivity is generally denoted as capital K, denoted by capital K. Okay, this hydraulic conductivity capital K can be written as small k, which is permeability. This is permeability of soil, okay, into unit weight of the soil, sorry, water, and viscosity of the water. Okay, these are water properties or fluid properties in the soil. Okay, the whatever fluid or water which is existing in the soil, those properties are in the bracket. The gamma W for the timing, assuming that water is there in the soil, and viscosity of the water. If it is multiplied by the permeability of the soil, you will get the hydraulic conductivity of the soil. Now, permeability of the soil can be written as, it is proportional to diameter or void ratio. It is proportional to the void ratio. So whereas you can write the formula as CD10 e power 3 1 plus e. Okay, this is the formula for small k permeability. So it is proportional to the void ratio and it is proportional to the effective size of the soil. Okay, D10 that is called. Now whenever void ratio is more, according to this permeability is more. If permeability is more, void ratio and diameter, it is also proportional to the diameter of the particle. Now here in turn this k is also proportional to E and D10. So generally void ratio will be more for higher grain size and less for lesser grain size particles. Now we'll discuss how the thing clay and all they are divided. First we'll draw a diagram that clay, silt, sand, then gravel, cobbles and then boulders. So this is the order of size. See, increasing order, increasing order of the size of the soil particle. Okay, this one. So here clay is having lesser grain size particles, then silt, then sand is more than this, then gravel size is more than the sand, then like this. Now whose void ratio? Void ratio will be more for more size particles, more grain size particles. So here if you take gravel, then gravel will be having more void ratio compared to the sand, then sand will be having more void ratio compared to the silt. Like that void ratio will be, void ratio increases, okay, in this direction. According to that, K is proportional to the void ratio, right? Now hydraulic conductivity will be more for the more void ratio particle, more void ratio soil. So we'll see what are given: CH, ML, SP, SW. CH, ML, SP, ML, SP and SW. Okay, here what are these referring to? We should know. C for clay, okay, M for silt. M is generally referred for the silt, S is for the sand, and here also S is for the sand. This is just the property of the soil. See, W means well graded soil, okay, well graded soil. P is poorly graded soil, poorly graded soil. Then L means low compressibility silt, H means high compressibility clay. Now coming to the keeping the properties aside for the time being, so what is the which is having more void ratio? Sand is having more void ratio than the silt, silt is having more void ratio than the clay. We can arrange sand first, and here options, let us see what is asked. Decreasing order of the hydraulic conductivity, that means you need to give more hydraulic conductivity first, then less hydraulic conductivity at the last, then it will decrease. So this is increasing, so we should reverse it. First sand will come, then silt will come, then clay will come. So this is the decreasing, this direction is decreasing K value, okay. Now in this sand we have two things. See, always you should remember that well graded will be having more permeability, more permeability, okay. That's how SW, well graded, will be first, then poorly graded will be second. Anyway, coming to the next one is silt, ML, and CH. So wherever this order is there, that is the answer. So we'll write SW comma SP comma ML comma CH according to the given. So where is it? SW comma SW is here only. So this is the answer. Okay, according to this is equation. This equation is actually given by the author. If you want to know the author name, Kojini Carmen. This is Kojini Carmen equation, this equation. So this is hydraulic conductivity, this is permeability, then these are the properties of the fluid which is existing in the soil. According to that, now according to this equation, you can find out the hydraulic conductivity order. So any doubts in this question? Can I go to the next question? So I'll be going to the next question then. Slide number 3. Yeah. Hello? Tell me. I didn't get you. Can you come again? Can you come again? I didn't get you. So I'll be moving to next question then. Okay. Just a minute. Yeah. So this is the question which is the second question in this session. This is the third session. By the way, I forgot to mention this is the class 3 which we are having in this. So in this again set 1 question number 31, okay, which is of 1 mark. So here it is asked that he said that an uncompacted heap of the soil. Let me just allow the people. I hope everyone can see the slide which is having the question number 31. So I am reading that an uncompacted heap of the soil has a volume of 10,000 meter cube. So its total soil volume is 10,000 meter cube and void ratio E, this is V, this is E, equal to 1. And if the soil is compacted now, then of course after the compaction what will happen? The volume of the soil will be reduced. So this after compaction, let us say this is V2, this is V1. After compaction it has become 7,500 meter cube. Okay, then the corresponding void ratio of the compacted soil is what? So let us say this is E1. So what is E2? And round up to 1 decimal place. So we need to find out what is E2. Before that, we need to find out. First, we need to know what is void ratio. I hope everybody knows what is void ratio, but I just want to ask whoever is in the third year BTech or Bachelor of Engineering, those people, if you can respond, can you know, do you know what is void ratio? Any one of you who are in the third year BTech? Can someone respond? Volume of voids to? Okay, 1 minute, be online. This is what you said? Yeah, you are in the third year?
No, sir. Second year, second semester.
Achha, then how do you know? I hope generally soil mechanics starts in third year.
Yes, sir. Andhra University we were introduced to soil mechanics one in second year, second semester.
But as it is August, how can it be second semester? It should be first semester, right?
Because in NIT's IITs they are currently in third year.
Okay.
We completed our second year this second year, second semester.
Okay, fine, fine. Anyway, so yeah, that's good. Anyway, that means the class is people know what is void ratio, but still I'll explain. See, VV corresponds to volume of voids, okay, and Vs corresponds to volume of solids. So coming to the three-phase diagram of the soil, let us say this is a soil box which is having total soil. So then what I'll do, I'll represent the height with the volume. This is total volume of the soil. This soil can contain solids. So this is hypothetical diagram or imaginary diagram which is not possible in real, because I am taking all the solids into this part. This is volume of solids. Okay, you can't actually bring all the solids together without any void in it, but this is just a hypothetical diagram. Now this is volume of solids and this is volume of voids. If you combine them, then you will get the total volume of the soil, which is denoted by just V, right? Now these voids can be filled by water or air or both of them together. So that is, so if both are there, then air can be there, water can be there. This is solids, okay, remember this is solids, right? Now suppose you are compacting by a load, okay, by applying some load, then what will happen? Air from the soil, suppose I'll take like this, okay, there are voids are more, it is just loose soil, I can say a loose soil. What will happen when you apply load? These particles get closer, that means air is getting out. That's how now after applying load they can be compacted like this, okay, they can be closer. Then what happens? Air is getting out, that's how it is compacting. Here air or water, anything can go out, but the solids, these are the solids, okay, these are the solids, those solids volume can never be decreased, that will be same. Even though you are compacting, they can come close, but the volume of the solid cannot decrease, only total volume can decrease. Total volume is decreasing means only VV is decreasing, remember, only VV can decrease, that's how total V can decrease. Vs cannot decrease, Vs is always constant. What you should remember is, here Vs will be always constant, okay, always constant. V can change, how? Because VV is changing, VV can change, right? So now coming back to the void ratio, what I'll do, I'll write void ratio volume of, this is the ratio of volume of voids to the volume of solids. This is the definition, right? Now from the definition again we'll go back to the question what is asked. V1 is given, V2 is given, that means total soil volume is given, and E1 is given, E2 is to be found out. Let's see. So here volume of voids is there, volume of solids is there, but just a minute, I'll admit people, okay, here volume of voids is given, volume of solids is given in this, but there is nowhere total volume, right? Total volume is not there in this formula. As the total volume is given in the question, I just want to bring this total V into the formula, in this formula, or I can change something. So what can I do? What I'll do is E equal to volume of voids, so volume of solids, okay, then as we have seen total volume is always equal to, sorry, I'll just, okay, so here total volume is always volume of solids plus volume of voids. As we have in this volume of voids, air can be there and or water can be there, anyway. See, now what will I do? In place of VV, I will write V minus Vs. If you deduct solids from the total soil, you will be getting only voids, right? What I'll do then next, V by Vs minus Vs by Vs equal to 1, right? Now I'll bring, somehow I'll bring Vs to the left side. Okay, that is my aim. I'll tell you why I am doing that. Okay, V by Vs equal to E plus 1, then Vs equal to V by 1 plus E or E plus 1. So why did I bring this to the left side and remaining all to the right side? Because this is constant. Okay, every time if you take a soil, okay, you are taking a soil here at first stage, let us say you are compacting. Okay, after compaction, now soil has reduced, it is in the second stage. Same soil, I am not changing the soil, I am just compacting. So their volume of solids will not change. That is the reason why I just want to bring this left side. So total volume can change because E can change. If he is changing, V will change, but at the end this ratio will be same, so that Vs will be same. That is what my aim to bring this. Now what I'll do, Vs equal to V by 1 plus E. Okay, Vs1 V1 by 1 plus E1, Vs2 V2 by 1 plus E2, right? So anyway Vs1 equal to V2, they don't change. Then I'll write V1 by 1 plus E1 equal to V2 by 1 plus E2. Okay, so just let's substitute the values which are given. V1 is 10,000, V2 is 7,500. Okay, 10,000, 7,500. Then E1 is what? E1 is 1 plus 1. So here E2 is to be found out. Can one of you tell me, this is 100 by 2 is 50 equal to 75 by 1 plus E2. Then can you tell me, one of you, 25 in 2s are 25 3s are, then 2 plus 2E2 equal to 3 minus 2, E2 equal to 1 by 2, E2 equal to 0.5. Is there any doubt? Is there any doubt? Can one of you or somebody, so it's solved. Now E2 is 0.5, right? So this is how you should solve, right? Okay, so we'll go to the third question in this session. Let me read this first. This is 32 question number in the set 1 paper of GATE of 1 mark question. A concentrated vertical load of 3000 kilonewton is applied on a horizontal ground surface. Points P and Q are at depths of 1 meter and 2 meters below the ground level respectively along the line of the application of the load. Considering the ground to be a linear elastic isotropic semi-infinite medium, the ratio of the increase in the vertical stress at P to the increase in vertical stress at Q. Okay, so this is what, just be online. So here let us say this is Q. Q is given 3000 kilonewton and it is applied on the horizontal ground surface, and points P and Q are at depths of 1 meter and 2 meter. So what I'll do, I'll draw a rough, this is rough. Next, in the next slide I will draw a neat diagram again. So there are 2 points One is P, one is Q. P is at a depth of 1 meter, okay, 1 meter. This is P, and another one is Q, which is at a depth of 2 meter, okay. This is the ground level, and these two are exactly under the below the ground, respectively along the line of the application of the load. Suppose a application of the load is at this point Q equal to 3000, okay. This is exactly below the 3000 kilonewton. Considering the ground to be linear elastic and isotropic semi-infinite medium, the ratio of the increase in, see, can you see the slide? Can one of you confirm? Yeah. Yeah. Now what happens when there is a load? There is in situ stress. In the last class we were discussing, okay. There is some in situ stress. Let us say this is gamma, soil unit weight is gamma, and this is 1 meter. So what is the stress at P? What is the stress at P? It is gamma into H, where H equal to 1 meter. Suppose gamma is 15 kilonewton per meter cube. 15 into 1 equal to 15 kilonewton per meter square. This is the stress at P, right? So if there is 3000 kilonewton which is applied at the ground surface, there is some increase in here. It will not be 15, it will be something else. That extra is delta sigma, okay. Now finally it will be delta sigma plus sigma initial, right? This delta sigma, there is a formula given by Bosinic. So Bosinic has given a formula to find out the increase in the stress. You wherever you take, you can take here, anywhere in the 3D medium, you can find out the delta sigma. So formula I'll write first and I'll explain that, okay. It's not working anyway. Yeah. Happened. There is some issue here. No problem. What is this? Sorry guys. Bosinek's theory, according to this, see, some assumptions are there. That is, those are the assumptions which are given in the question. Some problem is just let me just check this. there are some assumptions. That is called those are the assumptions like soil is homogeneous, semi-infinite, isotropic, and the load should be point load. Okay, it cannot be a pressure or aerial load through which we can find out the increment in the stress at any point. It is not the aerial load. Remember, it is only point load, and it is elastic medium. The soil is. That is how the assumptions. So in this, these are nothing but assumptions. So these are telling you indirectly that you have to use the Bose equation to find out the incremental in the stress. So yeah, yeah, 1 minute. Can you see now? No? Can somebody confirm? Yeah. So here in the question, these are given linear elastic, isotropic, semi-infinite medium, because these are the assumptions of the Bose theory, where you can indirectly understand that you have to use that theory. So Bose theory, you have to remember that point load. This is major one. You can't use when aerial load is given. So anyway, there is a concentrated means point load only. Now equation is delta sigma three by 2 pi 1 by 1 plus r by z square into q by z square. This is the formula. For you can just see the any standard book. I can't derive this now. So this is the formula which you should remember. You can't derive in the exam, right? You should remember this formula at any cost. So 3 by 2 pi into 1 by 1 plus r by z square whole power 2.5 5 by 2 into 3 q by q by z square. See, this is constant, these are all constant. You should know what is r and what is z, what is q, what is z. Q is the load, point load, which is applied due to which stress will increase. And then what is r? Suppose I'll just draw a 3D. This is ground, let us say. So at this point you are applying some load, let us say q. Okay, this is below ground level. Just this is below ground level in this direction. Now if you take a point, let us say P1, there is some depth, that is Z. But if you take a point here which is away from this vertical line which is passing through the application of the load, it is somewhere here. So now this is R, so it is in this direction, let us say X, okay, and this is Y. At this position this P2 is there. So this is R, the minimum distance between the point, the horizontal minimum distance between the point and the application of the load. This is Q, this is R. How to find out the R? First you will go in one direction, let us say X direction, then you will come Y direction. You can find out R square equal to X square plus Y square, right? R equal to under root of X square plus Y square. Or else if you are directly given R value, you can directly use this R. So this is the distance. You can say from here this is R, this is X, this is Y. So the direct distance, the minimum distance, horizontal distance between the vertical line application through the application of the load and the point. So you know the R now, you know Z, the depth at which this is Z, and the Q is the load which is applied. So this is how you will find out the increment in the stress, right? Now we will there is some problem here with this. Yeah, see, sorry, that is deleted actually. There is some problem with this. I'll check later in the next class. It will not repeat. So I'll just write 3 by 2 pi 1 by 1 plus r by z square whole power 5:2, then into q by z square. Okay, now here what is the r, as it is given in the question. What is given in the question? Q, P and Q are exactly below the application of the load, right? So what is the r value here? Can someone tell you? So r is 0, right? If r is 0, what is this term? It will become 0. If it becomes 0, 1 by 1 it becomes 1. So 1 power anything will be 1. So now it has become 3q by 2 pi z square delta sigma. Now here we will submit the given values, delta sigma 1 or delta sigma p at p. So at p is at the distance of 1 meter below the ground. So 3q by 2 into pi into 1 square. So what is delta q? Again 3 into, because of the same load they have asked, 2 pi 2 square, because z is 2 here. Now what did they ask in the question? The ratio of the increase in the vertical stress at p to the q. So they are asking delta p by delta q. There is big problem here. I don't know what happened. So delta p by delta q asked in the question. So now 3q everything is same other than this 1 square and 2 square. So what will happen? This divided by this, you will get 2 square by 1 square, which is 4:1, right? So here it is asked, the answer is 4. Do you have any doubt here? No, right? Okay. This one? 31 or 32? Yeah, there is some problem that is getting deleted. I don't know why. Let me just check again. It is getting deleted. See, it is deleted here. Anyway, here you want to see the calculation of this? Shall I complete? Okay. Yeah, anyway, here it is 1, E1 is 1, whereas E2 is to be found out. From this, acha, fine. I hope you can see now. I hope you can see now. It's not? Can't you see the slide? You can see the slide, right? Yeah. So can you see the calculations now? Yeah. So that's how you can just do the things here this will become 50, 25 2s are 25 3s are, then E2 will be 0.5. Okay, that's it. Yeah, here again this is also deleted. This delta P equal to 3q by 2 pi 1 square, whereas delta Q equal to 3q by 2 pi into 2 square, right? So the question is delta sigma P delta sigma Q, then 2 square by 1 square equal to 4:1. Answer is 4. Okay, I hope there is no doubt in it. So we have finished that question. So shall we go for the next question? Can you see the question? The final question of for this session is it is actually site investigation question. The question is related to the site investigation. The question number is 33 from the set 1 again, which is of 1 mark. Okay, see, I think if, see, who is that? Can you mute yourself? Yeah, see, the major part of the soil mechanics or geotechnical engineering is site investigation. Okay, in the site investigation, what you have to do, generally we go for some in situ test. In situ test means you will go with the instruments to the field, then in the field itself you will do some tests, then you will find out some parameters from them. So generally what does soil has? Cohesion, okay, then friction. So these are the main shear strength property parameters of the soil. So these two can be found from the lab or from the in situ test. So there is vein shear test is one of the tests which can be done in the laboratory or in the in situ also. Like that there are some tests, and also if you, some of you know that SPT test, standard penetration test. Okay, it is called standard penetration test. Like that there is one more test. I don't know whether you have come across this test in your BTech level. I don't know whether they have introduced recently, because when I was in my BTech this was not there. That is CPT. CPT was not there in my BTech. Maybe as this question is asked, you must I think you must have been taught in this generation maybe. Anyway, so that CPT is called cone penetration test. Cone penetration test. This standard penetration test, what, there will be a sampler. Suppose this is the ground level. Okay, there is a sampler above which you will tamp it. You will give some blows. Okay, so that's how it goes down. So when it goes down, the number of blows, depending upon that, you will find out the cohesion or friction. In the same way, here CPT is not that kind of test where you will give blows. So CPT, the instrument looks like this. There is a cone. Okay, so there will be samplers. Suppose this is ground level. So it is continuously, it is a continuous, there will not be any blows. It's not dynamic. You can dynamic cone penetration test is also there, but in the question if you see, it is static. Static means quasi static. Quasi static means it continuously goes. So it doesn't disturb soil as it disturbed in the SPT test. This is SPT, where in the SPT test it disturbs soil because you are giving blows, you are tamping with hammers above it, whereas you don't tamp here. You will just apply continuous load, it continuously smoothly it goes down. So whenever it goes down, what will happen? There will be resistance from the soil. This is all soil, right? So there will be resistance from the soil. So the resistance will come here at the tip of the cone penetrometer, and the resistance can come around the surface of the around this surface, total surface. So friction and bearing, there are two things which come into picture. These are both are called resistances. Okay, the resistance can come from the bearing tip. Okay, it can come from here, or the soil can have the resistance along this surface, that is called frictional resistance. One is tip resistance, which is also bearing resistance, tip resistance, and another one is frictional resistance. So both resistance, summing them together, you will get the total resistance of the CPT. So if you get total resistance, you will find out the cohesion and friction. There will be some formulas. Okay, there will be some formulas. So what is given in the question? First we will read the measured point or tip resistance, QC. It is also denoted by QT. Okay, that is given 1000. So QC is given kPa. Okay, that is tip, remember. And another one is given frictional resistance, so frictional ratio. Okay, FR is given 1%. And what is the value of sleeve friction? That means side friction. Okay, so here again the problem has arrived. I don't know what is happening with this. Anyway, just forget about this. In the question QT is given, FR is given. I'm so sorry, I don't know what is happening with this, but it's fine. We can close this session by this. So here you should know what is frictional ratio first. What is frictional ratio first? Frictional ratio definition is it is the ratio between the sleeve friction and tip resistance. See, it is what the name itself is frictional ratio, frictional ratio, right? That means you should remember that frictional resistance will come above, right? So that's how the formula, this is the formula, just formula. Now what are given? This is given as 1%. 1% means what? 1 by 100. And QS to be found out, that is the sleeve friction, frictional resistance. And QT is given as 1000, right? Now what is QS? It is simple, very simple formula it is. QS is 10 kPa, that's it. This is single 1 mark question. If you know the formula, you can easily write. So 10 kPa, that's it. So this is all about today's class. This is the answer. So do you have any doubt from today's class? I hope no, I will repeat all the 4 questions just like that verbally only. I may not show the slides because it is getting deleted or added something. First we have done soil classification, where permeability or hydraulic conductivity, which soil has more permeability or hydraulic conductivity. Gravel will be having more than the sand, then clay, then silt. So you should remember well graded soil will have more permeability or poor well graded soil or well graded sand will be having more permeability. So that's how our option was well graded sand greater than poorly graded sand greater than silt greater than clay. That's how the first thing is done. Then void ratio. If you know the concept of void ratio, you can solve that second problem. Void ratio is what? Volume of voids to the volume of solids, the ratio. So if you know that volume of voids by volume of solids is E, then you can find out, and V equal to Vs plus Vv. That's how you can solve that second question. And third question is, it's about the Bosenick's theory, increment in the stress. If you know the formula, it is very easy. You just have to substitute the values. That's it. Okay. And the third one and the fourth one is the frictional ratio, where you have to remember the frictional ratio formula. That is the definition of the frictional ratio is Qs by Qt, where Qs is frictional resistance, Qt is tip resistance. So you have been given Qt, you have been given Fr, you can find out Qs. That's it. So I think everything is done for today. Is there I think I can close the session now. Can someone of you can confirm? Can I close the session?
Okay, sir.
What? Yeah, actually now you can get the videos of individual questions separately. Okay, it's not that you can get the video of this session. That is little difficult, but we are again recording the videos for each question whatever I am teaching here, right? I am recording again those questions. That recorded, yeah, I will give you the link. I have to give you the link through proper channel. First I have to contact the body which is conducting this session, then from there you will get. Okay, no worries, you will get. You can watch anytime. Okay, then I will give you in by next class. I'll try to give you the videos. Okay. Hello.
Excuse me, sir. I am
Yeah, tell me.
about the practice sessions.
Practice session.
NPTEL, our civil tests are not there today, sir. You can help out.
Mock test. You want to like you want to attempt some mock tests?
Three branches have allow for writing mock tests.
Okay. Acha. So from the civil engineering, you are not having that mock test link or something, right? So you.
Civil engineering,
Mm.
there is no link for that.
Okay. So I'll ask them to give that mock test links if they have with them. So let's see. Okay. Okay then. So I'm closing the session. Is there anyone having doubt? Yeah. Okay then. Thank you. Thank you. Thank you. So I'm leaving the session. Bye bye. Have a nice day.